Greetings, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to continue on with a more in-depth look at some of the vocabulary that goes on inside of our circles. So please copy down your title, Vocabulary of Circles, as well as your objective, which is the student will acquire advanced vocabulary for lines and segments interacting with circles. As always, press pause anytime you need more time to continue your notes and hit play whenever you're ready to move on. All right, let's get to it. Now, as we said a couple of lessons ago, so our special shapes always have special vocabulary that goes along with them. We have seen a little bit of this over the last couple of days, but today you're going to see kind of a flood of new terms. Okay, so we'll start off with one that we already said. Okay, so if you've already got it copied down, good for you. Go ahead and write it down again. It can't hurt. Maybe we'll actually learn it. A circle is a set of all points that are equidistant from a given point. Okay, so that definition you have heard before, and there is a very crude diagram of a circle. Again, starting off with some reference point, which we call the center of the circle. If you measure the same distance in an infinite number of directions away from that center and place points at the end of that measurement, then eventually they will crowd together in such a way that you cannot tell the difference of the in between the points, and basically they construct the circumference of the circle. Circles are named after their center point. Okay, so just like everything else in geometry, we announce what kind of a structure we are talking about. In this case would be center and or a circle, and then whatever the name of the center point is. Okay, so that's review. Here's a new one. The term is chord, spelled slightly different from what you would be thinking of as like a cable being a chord. Okay, this one's more like the musical term chord. It's got an H in it, so C-H-O-R-D. And it is a line segment that has its end points on the circle. A line segment that has its end points on the circle. So here's a diagram that would just exemplify a chord. Certainly not the only one that's out there, but this is one. Okay, you can see clearly that we have endpoints on the circle itself, and the line segment passes through the interior space of the circle. It does not do anything in particular. It does not have any special properties. It is just the structure passing through the space of the circle. Okay, so a statement of the diagram that's shown would be line segment AB is a chord of circle C. Now, a special kind of a chord is one that you have discussed in the past, back in your days in junior high and possibly even elementary school, and that would be a diameter. A diameter is nothing more than a chord that has a special property, and its special property is that it must pass through the center of the circle. Okay, so a diagram, obviously I don't think you need a diagram, but I always give you diagrams to go along with your definitions, is your chord. AB, in this particular case, is a diameter of circle C because it passes through the center point, C. Okay, so nothing new there. You've heard of that one before, as you have heard of this one as well. Okay, a radius is another type of line segment that interacts with our circle. And as you all probably well know by now, a radius is a segment that has one end point on the circle, the center of the circle, and the other on the circumference of the circle. There's a diagram to go along with it and a statement about line segment AC being a radius of circle C. Now, while you're copying that down, I'm going to use these next few seconds to remind us that I realize that some of this information is old to you and some of it is new to you. And whether it is new or old, your assignment on your notes is to copy down everything. So it's not at your discretion to decide, oh, I already know that, I don't need that, oh, I can remember that, I don't need to write that down. If you want credit for your notes, then you copy all of it down. Now there is a relationship between the two line segments that we are looking at on our screen right now. And of course the relationship is that a radius, obviously, since it only goes halfway across the circle, it measures half of the length of the diameter. Okay. Another way to think about that is that the diameter, as it passes all the way across the space of the circle, that it will measure twice as big as the radius. Okay, so two different ways to think about it. I don't care which way you remember it as long as you get it remembered. Diameter is twice as big as the radius, or the radius is half as large as the diameter. Okay, the rest of these structures you are likely never to have heard of before, so let's take a look at them. Now, as we have lines and rays and line segments and things of this nature passing through two-dimensional space, they may hit our circle, coming from the outside in or the inside out. They may pass all the way through our circle, stuff like that. Okay, so that's what we're looking at. A new definition we're going to have now is actually a term that we have talked about this year under a different definition, and that would be a tangent. Okay? If a line were to intersect a circle only one time, then that line would be called a tangent of the circle. Hopefully you remember the term tangent. We talked about it when we were doing our trigonometric ratios in our right triangles earlier this year. The tangent that we talked about there and the tangent that we're talking about here are the same in some aspects but different in other aspects. This one location that the tangent touches the circle is called the point of tangency. Okay, now this tangent has to intersect the circle in a certain way. Sure, it only touches once, but what does that mean? It touches the circle and then stops, does not go all the way through the circle? That's not the way a tangent behaves. What we mean when we say it only touches the circle once is we're saying that the tangent basically just skims off of the perimeter, off of the circumference of the circle. So it just kind of nicks it on the way by. I always think of like a tangent. If you're a baseball fan or a baseball player and you've ever seen the pitcher throw the ball, the batter takes a swing at the ball and the bat nicks it, but the ball continues on and goes back to the catcher and he catches it anyway. Okay, then probably if you were to draw that scenario out, what we just saw was the path of the ball being a tangent as it hit the bat. The place where the ball nicked the bat is called the point of tangency. And there's actually a lot of math theory that revolves around circles and tangents and points of tangency, but that's more of a calculus discussion. Anyway, statement of tangents here, or of this diagram here, is line AB is a tangent of circle C. Okay, and we would say that is a tangent of circle C because it does make contact with the circle only once on the way by. And another statement could be made saying point D is a point of tangency. Now there's a very important property that goes along with being a tangent, and we are going to look at it in geometry, and here it comes. Okay, tangents, where the point where they make contact, that point of tangency, it causes the tangent to be perpendicular to the radius of the circle at the point of tangency. Okay, now that seems a little strange, but here's a diagram to kind of solidify that for you. Okay, as line AB comes by and it nicks our circle on the way by. Okay, if you were to draw a radius connecting that location, then that radius is going to be perpendicular to our tangent. Okay. Now, this is going to open up a different can of worms because, as we well know in geometry, anytime you have right angles, then we can build right triangles. And if we can build right triangles, then we unlock Pythagorean theorem, SOHCAHTOA, all of that kind of stuff. Okay, so right angles are very important to what we do. They help us solve all kinds of stuff. Okay, now a little bit more information on tangents. This is less known information, but there's no sense in us talking about tangents and not getting it. Okay, there's another term called a common tangent, and all a common tangent is a fancy expression that simply means we have one tangent that is, or one line that is being tangent with more than one circle at a time. Okay, so I'll give you a diagram of that here in just a moment. Okay, and tangents, common tangents are actually broken down into two subgroups, and the subgroups would be internal and external. If the tangent passes around the circles, meaning it does not pass through the space between the two circles, then it's what we call an external tangent. But if it passes between the two circles, kind of going through the space in between them, then it's what we call an internal tangent. Okay, so here's a diagram of a couple of circles and a couple of lines intersecting them. Okay, now you can see that the green line RQ and the red line ST, these are both common tangents because they're both tangent to each of the circles because they only make contact with the circles in one place. Okay, but you can see that line RQ stays away from the space that is in between the circles. So he's what we call a common external tangent, and the red guy passes between the circles. So it's what we call a common internal tangent. Again, this is not vocabulary that we see a whole lot in geometry, but I would really hate for you to get to the end of the semester and then something very easy like this pop up and surprise us because we just didn't talk about it. Okay, so there's your information on tangents. There is another structure that interacts with our circles. It won't take us nearly as long to talk about, and here it is. Okay. If a line were to come and intersect our circle twice, that would be called a secant of the circle. And a little byproduct of being a secant is since it enters the circle and goes out the other side of the circle, a secant actually contains a chord. Okay, so here's an example of a secant. Okay, clearly the line AB comes, it hits the circle, it enters into the interior space of the circle, and then hits the circle on the far side and leaves again. Okay, so that is clearly a secant, makes contact with the circle in two different places. Okay, so we could very easily say line AB is a secant of circle C, and we could also state that secant AB contains chord DE. Okay, so as we get more and more vocabulary going along with the circles, you can see that some of the vocabulary starts to actually interact with each other, as we have here, secant and chord. They are part of the same structure in some cases. And as you can imagine, we could run secants into each other and cause inscribed angles or cause vertical angles, in which case we'd have secants and maybe tangents and chords and diameters and radii and all that stuff, central angles, inscribed angles, all of that going on in a diagram at the same time. So again, as always in geometry, very important to know your vocabulary. It's important enough at this point that I'm going to say, you know what, we're not going to have any assignment tomorrow in class. Okay. However, there will be a quiz tomorrow in class instead of a worksheet. So if I were you, what I would do is I would find some time between now and about 10 minutes into class to spend a significant amount of time learning my vocabulary. Okay, so as I said, I'll give you a few minutes at the beginning of class, but a few minutes is not going to be enough all by itself. So find some time to study. Show up to class prepared on your vocab. That also includes information about central angles that we did a couple of times ago and information about inscribed angles from last time. Okay, so I appreciate you finding time to do your notes. I will see you in class for your quiz.